All right, wonderful. So in this video, we're going to talk about input efficiency, which is to say that we're going to think about how to allocate productive resources, right? People, machinery, land, things like this, to different industries that are producing different output. And our goal is going to be, first of all, to think about what efficiency looks like here, right? Meaning how we know that we're allocating people and land and all this stuff to different industries in a way that doesn't leave anything on the table, right? Where we couldn't produce more of everything. And then we're going to think about whether competitive equilibria, right, competitive market forces, lead to an efficient outcome, and if so, why? So to start off, right, the way that we're going to attack this, just like we did last time, is let's imagine an incredibly simple economy. So let's imagine that we've got just two inputs in production, let's say labor and land. And let's imagine that we've got perfectly inelastic supplies of both. So there are exactly 250 workers, and there are 1,000 acres of land. Cool. And using this labor and this land, we've got two different productive industries. We've got the avocado industry and we've got the strawberry industry. Awesome. And our goal is going to be, right, to think about how we ought to allocate workers and capital between these two industries, right, the avocado industry and the strawberry industry. So because we have a fixed amount of labor and a fixed amount of land, right, we can graph all the combinations of labor and land that we could provide to, let's say, the avocado industry, exactly the same way that we did last time, right? So we can draw a graph where we've got land on the vertical axis, labor on the horizontal, right? We have avocados, and we can go from having 1,000 acres of land to avocados to zero, from 0 to 250 workers. And again, just like last time, right? Every acre of land that I don't use to grow avocados, I'm going to use to grow strawberries, right? And every worker that isn't used producing avocados is going to be used producing strawberries. So I can draw an Edgeworth box, right, to represent this, where everything I don't use to grow avocados will be used to grow strawberries. Right? So when I have 0 workers in the avocado industry, I'd have 250 in strawberries. Right? If I have 250 workers in the avocado industry, none in strawberries. Right? Likewise, when I've got 1,000 acres in growing avocados, I'll have none growing strawberries. When I have 0 acres growing avocados, I'll have 1,000 growing strawberries. Beautiful. Okay, great. So now we've graphically represented all of our combinations of labor and capital that we could allocate to avocados and could allocate to strawberries. What I want to do next is I want to step back from thinking about what's going to happen in a competitive market and think about what we would expect to happen in any sort of market, or really in any sort of institution that might organize production. So let's imagine, right, to think through this problem, let's imagine that we don't have a competitive economy at all, right? There's been a communist takeover of California. You've been put in charge of managing the Southern California agricultural oblast. And your instructions, right, your responsibility is to meet an avocado quota producing as many gallons of strawberries, as many tons of strawberries as you can, with whatever you don't need to meet the avocados quota, right? While producing as many strawberries as possible. Okay, so what do? You don't want to screw up this job, right? This is important. So the first thing you might want to think about is how can you meet your avocado quota, right? What combinations of labor and capital will produce enough avocados to meet your quota? So let's say your quota was something like 200 avocados, right? What we would do is we would say, well, if we want to represent all the combinations of labor and capital that produce 200 avocados, we just want to draw an isoplane, right? right? So we'd say, what are all the combinations of labor and capital that produce 200 avocados? Great, right? If we had more labor and capital, if we were above, we produce more than 200 avocados, right? If we were down here, we would produce fewer than 200 avocados, and we would get, let's say, fired. So now we've got all of our possible options, right? All the ways we can meet our quota. The only thing left is to think about what it will look like if we're producing as many strawberries as possible, given our quota. So let's pick a spot, right? Let's pick an option and see if it looks like our best possible choice. So let's say, just making up numbers here, right? Let's say that we had 150 workers and 200 acres of land devoted to growing avocados. So that would mean, right, that we would have 100 workers and 800 acres of land left over for growing strawberries. And if we wanted to know whether this was our best choice, what we want to know is how many strawberries can we get with 100 workers and 800 acres of land? How many strawberries could we get with alternatives on our isoquant? So to do this, why don't I draw an isoquant for strawberries, right? See how many strawberries I could produce with these inputs. And what don't I say, right? Again, just making up numbers here. Let's say that I could grow 100 pounds of strawberries this way. Okay. So looking at this graph, do we know whether we're producing efficiently? Do we know whether, right, we're meeting our quota in the way that produces as many strawberries as possible? Think about that for a second. So I'm going to argue that we're not, right? That there's an option, there are alternatives that would allow us to produce more strawberries while meeting our quota. And the reason I say this is because if we move in this direction, right, we're going to get more strawberries than 100. We'll be above our isoquant. And there's this whole area here that's above our avocado isoquant and above our strawberry isoquant. Meaning, right, that we could produce more strawberries without changing our avocado production at all, while still producing 200 avocados. So what will it look like if we're meeting our quota in the way that produces as many strawberries as possible? It'll end up looking something like this, right? We'll have to have a strawberry isoquant that touches our avocado isoquant just once, right? So that there's no options above both of these isoquants. If we're here, right, then we know out of all the ways of producing 200 avocados, we're producing in the way that grows as many strawberries as possible. And we'll call this input efficient. Right? Meaning, as we said before, that there's no alternative where we would get more of all of our outputs. Right? There's no alternative allocation of labor and capital to this one, where we would get more strawberries and more avocados, right? All of the alternatives, we'd have to give up avocados to get more strawberries, or give up strawberries to get more avocados. Okay, so this is an input efficient way of producing 200 avocados. Is this the only input efficient allocation of labor and land to the avocado and strawberry industries? Think about that for a second. So I'm going to say this is the only input efficient way of growing exactly 200 pounds of avocados, right? This is the only option where our isoquants just barely kiss and don't overlap at all. But it's not the only input efficient way of growing avocados and strawberries, right? We picked 200 at random. What if our bosses set an avocado quota of 300? Right, then we would have drawn an isoquant for A equals 300, and we would have wanted to find the input efficient way of producing 300 avocados, right? We would have ended up saying that our input efficient way of growing 300 avocados was something like this. Right, if our boss had asked us for 400 avocados, right, we would have had to figure out the input efficient way of growing 400 avocados. Right, maybe we would have had something like this. Make sense? And so what we can say is any number of avocados we grow comes with some input efficient way of growing it. And if we wanted to connect all of our possible input efficient allocations of land and labor to the avocado and strawberry industries, right? We would essentially draw a line connecting all of these points. And we would call this, much like we did when we talked about consumers, right? Much like when we talked about allocating beefaroni and water to Mod and to you, we would call this our production contract curve. Right? Where our production contract curve is essentially telling us all of the combinations of labor and capital where there's no alternative arrangement that would produce more of everything, right? So it's a curve going through every single input efficient allocation of inputs to industries. All right, cool. So that brings us to the question of how do we find our production contract curve if we knew the production functions in the avocado and the strawberry industries? Right, in other words, if we knew how many avocados we produce with some amount of labor and capital, we know how many strawberries we produce with some amount of labor and capital, how would we figure out the allocations of labor and capital to these two industries that don't leave anything on the table, right? Where we couldn't improve on it from the perspective of avocado and strawberry production. So the way that we're going to figure this out is by remembering that the way we found our production contract curve, right, our conceptual answer to how to find our production contract curve, is that we've got to figure out all the points where we've got two isoquants that just barely kiss each other and don't overlap at all. Right? The only way that we're going to have two isoquants that just barely touch and don't overlap at all is going to be if the slope of those two isoquants is identical. In other words, right, what we need is that our marginal rate of technical substitution, MRTSA of LA and KA, has to equal our marginal rate of technical substitution in the strawberry industry. Right? And if we think about what this is telling us, this actually makes a great deal of sense, right? Because our MRTS is telling us in each industry how many machines would it take to replace a worker, right? How much capital would it take? How much land would it take to replace each farm worker? So what we're saying is we need to have the same number of machines needed to replace a worker in avocados as in strawberries. And if that wasn't true, right, let's say that it took more machines to replace a worker in avocados than in strawberries, then we should take some more land in avocados to replace the worker than in strawberries. Then we could take some land out of the strawberry industry, give it to the avocado industry, take some workers from the avocado industry, give them to the strawberry industry, and improve production in both industries. Right? That would be, we'd have some situation like this where the MRTS is greater in avocados than strawberries, and we would say we ought to move in this direction. Cool. So let's take a specific example. Let's imagine that we have a production function in avocados, like f of a is going to equal LA to the 1/2 times KA to the 1/2. Right? We just have some nice Cobb-Douglas production function. And in strawberries, we've got f of s equal to some other Cobb-Douglas production function. Let's say ls to the 1/3 times ks to the 2/3. Right? Just making things up here. Just coming up with an example. So what we're going to do to solve this, right, is first of all, we need to find our MRTSs. Right? So we'll say our MRTS in avocados is going to have to equal, right, the f, the l, over the f dk, right? So this is going to be 1/2 L to the minus 1/2 times k to the 1/2 over 1/2 L to the 1/2 times k to the minus 1/2, right? So this is just going to be Ka over La, right? I'm blowing through this quickly, but hopefully you can take a minute to practice this yourself if you're still having trouble doing this, which is totally reasonable, by the way. And then our MRTS in strawberries, right, we're going to do the exact same thing. It's going to be the FDL, the FDK, which is going to be 1/3 L to the minus 2/3 K to the 2/3 over 2/3 L to the 1/3 K to the minus 1/3, right? So 1/3 divided by 2/3, I'll have 1 over 2 times again KS over LS. Awesome. So what does this mean? It means that when I want to set the MRTS in avocados equal to the MRTS in strawberries, I'll be setting Ka over La equal to 1/2 Ks over Ls. Cool. So this is pretty good, right? This is a good start, but we've got a problem. Our ultimate goal, right, is to find this curve, which is going to tell us for any value of La, how much Ka will we have if we're producing avocados as efficiently as possible. So we only want 2 variables. But here we've got 4, right? So we've got to come up with some way of figuring out what Ks and Ls are going to be in terms of Ka and La. So how do we do that? Well, remember, right, the capital that I use in the strawberry industry is just the capital that I don't use in the avocado industry, right? So I can say that Ks just equals 1,000 minus Ka, right? And likewise, the labor I use in the strawberry industry is just the labor that I don't use in the avocado industry, right? So Ls equals 250 minus La. So I can replace Ks and Ls here, right? So that I can say Ka over La equals 1/2 times 1,000 minus Ka over 250 minus La. Right? And from here I just have an algebra problem, although it's slightly more gnarly than the algebra problem we dealt with last time. Right? So I can multiply everything up. I can say Ka times 250 minus La is going to equal 1/2 times La times 1,000 minus Ka. Right? So 250 Ka minus La times Ka is going to equal 1/2 La times 1,000. That'll be 500 La minus 1/2 La times Ka. Right? So why don't I get all the Kas to one side? So I can add 1/2 La Ka to both sides here. I'll say 250 Ka minus La Ka plus 1/2 La Ka, so minus 1/2 La Ka equals 500 La. Yeah? Then I can just pull a Ka out here, right? So I can say this is the same as 250 minus 1/2 La times Ka. So I can get my production contract curve by saying that Ka is going to equal 500 La over 250 minus 1/2 La. Awesome. Okay, so this thing looks a little bit ugly. But let's take a minute to think about what it's telling us. So when we're producing hardly any avocados at all, right, when Ka and La are both really close to 0, this is telling us that Ka is going to be, I'm going to rewrite this with La pulled out here, right? Ka is going to be 500 over 250 minus a really small thing times La. In other words, I'm going to use something like 2 acres of land for every worker, right? 500 over 250 times La is going to be Ka. So when I'm producing very, very little, I'm going to have something like 2 acres of land for every worker. On the other hand, when I'm producing lots and lots and lots and lots of stuff, right? When I've got almost all of my workers working in the avocado industry, right? I'll have 250 minus 1/2 times something close to 250. It's going to be something like 125. Right? 500 over 125 is going to be something close to 4. So as I'm increasing production of avocados, I'm going from having 2 acres for every worker to having something closer to 4 acres for every worker. Why does this make sense? Well, if we look at our production functions, right, for avocados and for strawberries, we can see that strawberries are a more capital-intensive industry. Right? We can see, we said that avocados are going to be La to the 1/2 times Ka to the 1/2. Strawberries are Ls to the 1/3 times Ks to the 2/3. So what we're saying is essentially, once we're using all of our resources to make avocados, we're going to use labor and capital in the proportions that they exist in the world, right? We'll use 1,000 acres of land, we'll use 250 workers. But when we're not using very many avocados at all, we're going to produce in a fairly labor-intensive way in the avocado sector, right? We're going to try to use more workers per machine in the avocado sector than we will in the strawberry sector. So if we graph our real contract curve, our real production contract curve, it's going to look something like this, right? Where the slope down here equals 2, the slope up here equals 4. And essentially what this is telling us, right, is that as much as possible, we're going to be labor intensive in avocados and capital intensive in strawberries, because avocado production is relatively more labor intensive, strawberry production is relatively more capital intensive, right? And just as before, each point along our contract curve is going to represent a point that's input efficient, right? Like this. Wonderful. Wonderful. So far we've done a pretty nice job of understanding how we ought to fulfill our duties as the director of the California Agricultural Oblast. Right, we have a pretty good idea of how to organize production of the entire Central Valley in order to make sure that we're not leaving anything on the table, right, that we're going to fulfill our avocado quota in the way that produces as many strawberries as possible, right? We basically want to be somewhere on this curve rather than being somewhere off of it where we could get more of everything, right? Where we get more avocados and more strawberries by going somewhere on the curve. But this brings up the question, right? How does any of this affect, what does any of this have to do with a competitive equilibrium, right? When we have, instead of having an organized production system where we're carefully allocating workers and land to different productive activities, what happens if instead we've got a bunch of companies, right, buying up labor and capital, buying up labor and acres of land at various prices and trying to make as much money as possible? So to think about this, why don't we think about what a firm is doing when they're in a competitive market? Meaning, right, from the firm's perspective, when they're able to buy as much labor and as much capital as they want at prices W and R. Right? So in a competitive market, right, we'll buy as much L and K as we want at prices W and R. So what does this look like? Well, we know that in a competitive market, right, a single avocado firm, forgetting all about strawberries, right, the avocado producers aren't thinking about strawberries. A single avocado producer is going to choose to hire labor and capital up until they are minimizing their costs, right? However much output they're going to produce, let's say that they wanted to produce 4 pounds of avocados, right? A single avocado producer is going to choose labor and capital so that their MRTS equals the wage rate over the rental rate, right? The MRTS equals the cost ratio. So in order to cost minimize, right, avocado producers must have that the MRTS in the avocado industry, right, has to equal W over R. Awesome. How about the strawberry industry? What are strawberry producers doing? They're doing the exact same thing, right? They're also hiring labor and capital up until their MRTS equals W over R, right? So in strawberries, we've got to have MRTS in strawberries of LS and KS equal W over R. Well, what's this going to tell us? This is going to tell us that because avocado producers are hiring labor and capital up until MRTS equals W over R, and strawberry producers are also hiring labor and capital up until MRTS equals W over R, it tells us that when avocado producers and strawberry producers are both maximizing their profits, which requires that they're minimizing their costs, the MRTS of avocado producers has to equal the MRTS of strawberry producers. And what that means is that in a competitive equilibrium, when everyone's maximizing their own profits, we're going to end up being input efficient. Effectively, what's happening, right, is that every point along our contract curve, there's some wage rate exactly equal, right, wage and rental rate, relative wage rate, exactly equal to the ratio, the MRTS of avocado producers and the MRTS of strawberry producers, setting them equal to each other. And so the crucial point here, right, in a competitive economy, we're not going to get to input efficiency, right? We're not going to organize workers and capital in a way that gets us as many strawberries as possible, given the number of avocados we have, because anyone's working together or cooperating, or because avocado producers know or care anything about what's happening in the strawberry business. The reason we're going to get to input efficiency is because the fact that avocado and strawberry producers face common prices means that they're going to end up effectively choosing their levels of inputs in order to balance each other out, right? When capital becomes more important for strawberry producers, they're going to choose more capital to equal W over R. That's going to increase the cost of land relative to the cost of labor and push avocado producers to use more labor. So, right, both avocado producers and strawberry producers are going to be reacting to the relative price of labor and capital. The relative price of labor and capital, right, as I was just kind of talking about intuitively, is going to depend on the decisions of avocado and strawberry producers. And in fact, we can get that, again, by saying MRTS equals W over R. Right? MRTS in the avocado industry equals, we said KA over LA, and equals W over R. Right? Well, when we're producing in an input efficient way, we know what KA and LA have to be, right? Because we know that KA is going to equal 500 over 250 minus 1/2 LA, right? So that means that KA over LA is going to equal, oh, I'm sorry, this whole thing times LA. So KA over LA is going to be 500 over 250 minus 1/2 LA, and this is going to equal W over R. So what's this going to tell us? It's going to tell us that the wage relative to the cost of capital, right, when we're not producing very many avocados, when we're down here, is going to be about 2 to 1, right? Workers are going to earn twice the rental rate of an acre of land. When we're producing all avocados, right, when we've got lots and lots of avocados produced, the wage rate relative to the rental rate is going to be about 4 to 1, right? 500 over 125. And why this makes sense, because as we're increasing production in avocados, we're shifting from strawberries, which are relatively capital intensive, to avocados, which are relatively labor intensive, right? As a result, the relative value of a worker compared to an acre of land goes up. Okay, awesome. So this is all I'm going to say about input efficiency. In the next video, we're going to think about output efficiency. In other words, we're going to shift from saying, how do we produce our avocados and strawberries, to how many avocados and strawberries ought we produce in the first place.